Intermediate AutoCAD, CAD-117, video conference. Today's agenda is to go through Module 11 and to model this test fixture assembly. That content is located on the Content tab on Lab 11, excuse me, Module 11, here we go. It's project 11.2 from our textbook, Technical Drawing 101 with AutoCAD, and it's this mechanical working drawing. And what we're going to do is the same thing we did with the, I believe it's called a shoe plate model, where we created 3D drawings of the parts, created an assembly drawing with a bill of material and with balloons. There's some additional content in here that I do need to clean up. This used to be a portfolio module, how to create a portfolio. And we'll probably take that content and move it somewhere else. But at this time, we're just going to leave it as the test fixture, which if you don't have your book, you can download it, or you can click on it here. And this is how the drawing should look. I've got a CAD drawing also. So this is actually a pencil drawing, as you can tell by the annotation. 6 parts, base, pivot, plate, some nuts and bolts. Here's the pivot base with the dimensions, inches. Here's our pivot and our base plate. You can use the mechanical working drawing prototype from the textbook if you'd like to. Otherwise, B-size mech title block will be just fine. Since it is an inch drawing, those title blocks work just fine. And as we look at that, what we're going to do, I'm not going to go through the text material. I was considering it if we were to look at the chapter 11, and I guess I will briefly since it's on the screen right now. But when we talk about what our objectives are here, it's mechanical drawing for assembly. And so whenever you work for a company that has a product that needs to be assembled, when you have these 3D assembly drawings, they help greatly for people to pick the parts and to put them together. And so we're going to work on these assembly drawings, and ideally we are just going to show how to create these. With AutoCAD, you have to have a few techniques. So you would model these in model space and create a viewport in paper space, and you'd put the title block itself in paper space, and then the viewport kind of sinks inside of that. And then when we do the balloons and annotation, we can do that in model space also, but what you do is you get a isometric view, and then you type UCS, enter, and plan, PLAN, and what that'll do is it'll give you a perpendicular viewpoint where you can put these numbers on, and I'll see if I can explain that in the drawing part. So exploded drawings basically show how things go together. You have balloons. The balloons refer to title blocks, which have a bill of material, tells people how many parts they need, what the parts are. When we used to do this with the pencil, and I used to teach this course up at NIU, it was called Pictorial Projections. It's a lot of work. You have to have a drafting machine, a drafting table, ellipse templates, and you have to have these 30-60 degree ellipses to kind of pencil this in. But nowadays with computer modeling, we model the parts, and then it's just a matter of understanding the techniques for engineering graphics to be able to display them in a manner that is a standard. and this would be considered a standard. That's the idea behind the intermediate AutoCAD course. And so typically you'll use center lines to show how things go together, and the balloons then refer to parts lists. And then oftentimes you'll do a detailed drawing of each of the parts. So it's quite a bit of work. I'm only requiring the assembly drawing. And so if we look at the AutoCAD file, it is quite well developed. It doesn't have all the nuts and bolts in it yet, but this would be our assembly. As you can see, we're using the author's title block here, but this is just a viewport here. And then in that viewport, we have these balloons that point to the different components within the title block. Here's the base plate. And this is just a flat 2D drawing that we dropped off from our model. Here's our pivot. So there's quite a bit. We're requiring just this. And if we look at how this part is modeled, basically the way that I would start this part would be in a top view to draw this base according to these dimensions here. And then once you have that modeled, or you have that drawn to those specs, grab an isometric view. And typically I'll make a copy of the drawing. And so I'll just copy it. WP. Window polygon is better than the lasso. Lasso just seems to be uncontrollable. Give it a base point, and then just slide it somewhere in model space. And then as you start to model this, we don't necessarily need these dimensions. I probably should have got rid of them before. I do like having the dimensions as a reference for the measurements. And then if I take a look at the base, what we want to do is, we really can't take this chamfers. These are created because of the way this model was dropped off. So we'll have to put those in with solid modeling tools. And we'll change the workspace over to a 3D to do that. So just a bit of cleanup work, because as you start to work with AutoCAD, I still really like AutoCAD a lot. Although there are these other tools, and a lot of times people who've taken these AutoCAD courses will take a SolidWorks course, and then they'll go out and get a job at a company and they won't have SolidWorks. And they'll say, oh, you got to get SolidWorks, you've got to get it. And it's an excellent program for manufacturing and prototyping, but it's expensive. AutoCAD is like driving a Chevy, and SolidWorks is maybe a Saab or a Audi. So as we look at this, what I would do here would be to, I'm going to switch over to a zero layer. Let's go to an object layer. You want to put these onto one layer, and then you want to polyedit and join them. And then we could say p-edit and join, because you have to have boundary shapes as you do your modeling. So I'm going to extrude that a height of 1/2 inch. And we can go and switch over the workspace, 3D modeling, extrude. People tend to go for press pull all of the time, but it's sometimes a little bit too smart. These older school techniques allow you to precisely choose what you want to extrude and then direction of it. So I'm going to say 0.5. And then as we look at the other components, this hole here, we can press pull that, and when you press pull it, it'll subtract it. And the same for these other holes. And then if we take the other plate, and again, some of these things need to be tweaked because the drawing was generated from a model. So I'm going to remove this line, and we'll have to chamfer that. Just like these holes, we'll have to chamfer them. Or you can do the projection that we had to show how to do a spot drill. But I can extrude this in the Z height direction, and that's going to go 0.25. And then if we go back to conceptual, we can start to see it starting to take place. There's no real reason to do the other side in this video at this time, but we can do things like under solid, we can do things like chamfer edges. And so we can chamfer the edge of this part here. Before we set it up, we want to set up the distance. And so we'll take a look at that, and it's basically got a .5-inch chamfer for both of them. And then if I select this edge, I had a feeling that was wrong. And so we can add that chamfer in that fashion. And I can double check the print to see if that's, and the chamfer can also be added here as well. And so I can come in here and I can say chamfer edge and select the distance, 0.125, 0.125. Enter. And so we can create the geometry for that component. And I would do the same thing with the other part. You know, so as we start to go through and create the models, start off with I would basically draw this in a top view and model it according to the directions in the assignment. And so if we took a look at that, there's our old friend, the toe stop. So the dimensions are right here. And so as we look at it, we've got this outside radius over here, which is 2.75. And then we've got this inside hole, which is 1.52. So they've given it 20 thousandths clearance. I believe that hole is 1 inch for the plug that goes into it right here. And so you have to go and toggle between these dimensions to be able to read the drawings to put this together. But the modeling techniques are pretty straightforward. I would draw a top view of everything that you see that's flat here, and then press pull that up. And then for the ears, I would actually model them flat and then 3D rotate them 90 degrees and then attach them with an O snap about the midpoint and then copy it or mirror it. And you could model the entire thing flat before you did that. You know, if you were to make a rectangle and then pull it up and then try to radius it, it's much more difficult with this software because the fillet radiuses sometimes error out when they zero out at the top end of it. But other than that, you know, you draw this bolt hole circle pattern, 1.52. You can pull this geometry off of the other drawing, copy it, and then just offset the circles. But I don't think I need to put that into the video. And the same with this. You can draw this part in a top view, press pull it, or do it as a revolve. And then the tricky part is to be able to get this little stem. You know, it's kind of like a mushroom, and it's got this stem coming out of it. And so what I did is I drew it 2D flat, kind of like a bobbin for a sewing machine. And then I revolved it. But when I revolved it, when I was drawing it, I left a witness line right down the middle. And so I'll do that with AutoCAD. I'll draw a center line at 0.6, just jutting out, and then I'll use that center line to model off of for the stem here, this 1/2 inch diameter. And then this part here, you can just model flat or you can revolve it, and then it's a matter of putting it together and unioning it. So I think it's a bit of a challenge, but it's definitely a good test of your ability to do intermediate AutoCAD. And so that's the plan. The plan is then to work on module 11, and then next week we'll start the course review, and we'll have our final exam on the 6th, and then all work will be due the following week on the 13th. That will be a mercy day. Essentially, if you have everything in by the 6th, then you're good to go. Then the 13th is just there to submit any drawings that you may have missed. Okay, so I'm going to stop this recording and post this in the D2L. Just as a recap, module 11, test fixture assembly. Here's our part. Here's the completed test fixture. And then the instructions are in the content tab for module 11. And this ends today's video recording.